Our next speaker is Dr. Dustin van der Haar at and he's in computer science and software engineering at UJ. His work focuses on human-centered AI and pattern recognition for good, with applications in biometrics, medical imaging, medical image analysis, and sports analysis. He's an executive member of the SA Young Academy of Science and has collaborators all over the world in the UK, Germany, Japan, and Australia. And his talk today is going to be about using AI to perceive humans. Join me in welcoming Dustin.
Thank you very much. As you mentioned, I'm at the University of Johannesburg, specifically in the Academy of Computer Science and Software Engineering. And I always don't forget to mention the South African Young Academy of Sciences. We're trying to get the visibility out there. So for all you young scientists, please do, end of June, we take 10 new members of the best and brightest young academics. So please do apply. You can go have a look on ASIF and all that and get in there. Right, so I thought I'll start off with one of these. Can anyone tell me what one of these are? Very old? What are they? So maybe the younger members in the audience might not recognize it, but this was games, right? So we used to play some arcade games. I still have very fond memories in my old childhood home and my aunt's house around the corner, going to this puzzle shop, putting in the 50 cents and all your worries melt away for however long, right? So in case you're wondering, this is actually how I got into computer science. I know it sounds really silly, but I wanted to go work for Nintendo, right? What happened was when I went to university, I realized that you can actually solve problems. You can write software that actually does solve some good human problems. And so my dreams of Nintendo sort of got put to the side a bit, and I actually started working on more problems related to solving human problems. So what do I actually do? Well, in our group, we mostly focus on writing algorithms that actually perceive human beings. Now, human beings are very nuanced, they're very animated, there's a lot of things that are in there. But what's really strange is that they are very difficult to perceive for a number of reasons. They speak different languages. They do all sorts of weird things, right? You don't always expect them to do something where, for example, if I had to ask you, what is the person doing in this particular slide, what would you say? They're jumping, right? Now, what's really interesting is if I crop the bottom, maybe that could be different. And part of all of this makes it really, really difficult for a computer or machine to understand this. So what we typically tend to do in this type of space is there are abundance of different activities that we try and recognize for. And if we had to try and recognize all of them, it would be very, very difficult and very computationally expensive. So what we try and do is we specifically, we try and look at the various different components inside of what constitutes a human being, break that up, and then look at the different combinations as a mechanism to determine what exactly they're doing. And we do this, of course, across a multitude of different sensors. So whether it's vision-based data with cameras, microphones, or medical sensors, or wearables, and so forth. So at the very core level of all of this is let me give an example from a vision-based system. We take what we see in front of us, a human being, and we try and encapsulate some sort of latent representation that's useful within a machine setting. So we talk about a pose estimation scheme. Now, typically these pose estimation schemes constitute various different components where there's certain joints that are relevant to us. And this skeleton that we get there, those little stickmen that we always used to love to draw, that's the representation we're trying to gain as a computer. Now you think, great stuff, nice and easy, no problems, right? Now, the problem with this is getting to this particular skeletal representation is very, very complicated. So there's different ways of doing it, first of all. The one approach is, let me go look for different body parts, right? So I can look for a head, I can look for a torso, I look for some legs, and hopefully they're all in one place and it's not some Halloween movie that where there's parts running around, right? So that works to a certain extent, but it doesn't scale well. When it comes to the other nuance we can have is there can be all sorts of different emotional variation, and that, of course, we have to encapsulate as well. So the one example I always like to tell my class is they ask me, okay, can you please explain to us why do we need to learn about, so they're like, Prof, why do we need to learn about computer vision? I say, well, okay, fine. What do you like to do? And I remember this one class, and she's like, oh no, what do I do at home? The first thing I do when I get home is my mother tells me, there's the pot, you're going to go make some magwenyas. You need to feed everyone, right? So I was like, how is that going to help my life today? So I was like, okay, fine, let's do it. So you can train an algorithm to train for the brownness of when you have your magwenyas or fat cook, so that you can actually determine, okay, this is where you're going to stop and you move on from there. Now, why am I talking about this and why am I actually covering all this a little bit is so that that's my preface to, oops, we're getting there. Can someone click on there for the video? So I'm going to talk to you a little bit about my group, and then we're going to jump into some of the stuff we do and why I'm here in front of you talking about all this. You just have to click on the, anywhere in the middle, or spacebar. Not working. That's okay. I'll wing it. So what do? We specifically focus on, we write algorithms to encapsulate these human beings for various different human problems. Now, these problems reside in these key three areas. The first one being for protect, which is mostly security based, so in video surveillance settings and all that. Preserve, which is mostly related in medical, and there's a lot of other parts in there related to preserving different aspects. And of course, play, where we do a lot of sports AI and all that that comes with it. So some of the things we've done so far, biometrics, human aspects of, okay, we take a whole bunch of people and we take them to a fingerprint scanner. We don't tell them what it is, and we see what happens, right? And you'll see the most crazy things that happen. I've seen people look into with their eye into a fingerprint scanner. I've seen people trying to tap on it. I've seen all sorts of things. And what's really interesting is that aside from human beings very fascinating and creative, is that it's a good thing where if you don't have specific information that backs up what they're supposed to be doing, it can be very, very complicated how things go. So we've done a lot of work in brainwaves, specifically in can you use, for example, physiological signals like in order to identify people. So this is the emotive headset. We derive autoregressive coefficients, classify them with machine learning models, and we've determined that yes, you can identify people based on their brainwaves. We've done other variations of fingerprint scanners on all sorts of things like car keys and so forth. We've done esoteric biometrics like lip recognition. We've proven that just with lips, that's unique enough for every single person to identify people. For lip, I think the latest one we've got is about 0.89 equal error rate, which is very, very competitive to a lot of the face recognition algorithms that we've seen. We've also looked at face anti-spoofing. So let's say I bring in a photograph and say, this is me, and I bring a photograph of someone else and say, well, I'm masquerading as someone else. Can I detect whether what I'm putting in front of you is real or not? That artifact that you're putting there has repercussions in the latent space, and we look at different algorithms for doing this. And we're the current state of the art right now. And what we did was, on the right, first of all, we have the first face anti-spoofing data set in Africa. It was a number of years ago, and then we trained different algorithms because there's a lot of bias in terms of different ethnicities. And what we did was we also used data augmentation strategies for actually improving the accuracy of a lot of current state-of-the-art methods in order to beat them. The one on the right there, we use generative adversarial networks, if you're aware of, where we have these deep learning-based approaches where we follow this sort of adversarial process to generate candidates that are part of the original data set that look very, very similar as a mechanism for improving model robustness. We've done a lot of work in the preserve side, especially when it comes to language impairment detection. It's quite a big issue in society right now, especially in a lot of rural communities if you have a language impairment, they get isolated in many different settings. And one of the nice things about these algorithms is that when you put it on an app, you can just listen and say, well, this is what type of language impairment you have, and these are the resources nearby that you can go and pursue, and a few other things there. We've looked at different techniques for improving breast cancer detection. For those of you in this particular space, it can be quite difficult, especially when it comes to varying subcategories of breast cancer. So some of the work that we did in this space, for example, is to use particle swarm optimization for improving how exactly we update parameters in deep learning-based networks. We've also looked at genetic algorithms for converging on specific segmentation use cases for where the cancer is in the first place, as a mechanism for integrating into computer-aided diagnosis systems. And we've also looked at specific things like medical label detection for the vision impaired. We've got a great collaboration with Royal Holloway University and different colleagues in UJ. And we've had some good success in this particular one, got the app out and everything like it to help these individuals that I need. Another one that's quite fun. So I mentioned some of the food earlier. So different anticipation strategies. Can I take a video and actually make a recipe from the video itself? In principle, sounds like a very, very easy thing to do. It's extremely, extremely challenging. Why? Because there's a lot of context that's missing. So for example, when you say you're putting in this amount of powder, how much actually is it? Can you infer quantity information? There's a lot of nuance in different things that you would assume would be very, very easy, but it's actually extremely difficult to do so. And we've got some good success in terms of various different estimation strategies for those quantities as a mechanism for these recipes, as well as the sequence of events that have occurred. We've also looked at agricultural setting in terms of, here's a good example for hemp, detecting hydration in terms of, hemp plants take a lot of water. You want to give it the optimal amount of water. Can we actually detect what that optimal amount of water is over a period of time? And at the moment it shows signs of dehydration, that's using a vision-based approach to deliver the water mechanisms for that. And there's a few. I'm gonna get to my point. So we all want my baby is probably the sports AI stuff. So we do a lot of different AI in this particular environment for recognizing ballet poses. So one of the big projects we're busy on right now is, can we take choreography that's happening on a video and actually transcribing it in using Benish notation or anything like that. And it's a very, very interesting problem because choreographers that's their bane of their existence, to actually draw those little panels and all that. And another thing we're doing right now is we've got on TikTok, we've got this big project where what we're trying to do is analyze different footage and where people don't acknowledge original authors of different artworks in terms of dance works. We take those, get a succinct representation like a signature, put it in a blockchain, and then every new bit of information that comes through gets checked against that signature to see if there's attribution applied to it. And we've tried different strategies for doing that. So we do a lot of work in cricket. We've tried different, seeing if there's tendencies by certain players in terms of seeing if there's weaknesses that you can discover. And there's a lot of different tasks in there. There's a great example of backlift recognition in our latest scientific reports article. And this is a lot of the exciting work that's getting a lot of momentum right now. Got some work in the classroom. And we also have some work with the South African hockey team and esports and basketball and many, many others. Currently, we're busy with the World Cup stuff. You can see I have way too much stuff that I put in here. So let's talk about some of the challenges. So you're probably wondering, why am I here? talking about all this. Now, in the past, traditional methods, we could actually use desktop hardware. We could then move over to GPUs, and that was enough. The moment we pivoted from a billion parameter models, 100 million parameter models to billion parameter models, we struggle with desktop hardware. And that's why we moved over to more CHPC based infrastructure and cloud-based strategies and all that in order to train a lot of these models. And what's really a big need right now, especially in my space right now, is the ability to train these models and inference. And the demand is going to be significantly higher from this point onwards. There are some environmental challenges, some of the stuff that we don't touch with a long pole, when there's not a lot of light, a lot of big crowds, although we're still scared of going in those types of environments for a bunch of reasons. One particular challenge that we're facing right now, which I thought I'll share with you, is the next one, where we've got a whole bunch of people dancing. We can track all the people that can dance and all that. But here's the thing, right? The moment the camera starts moving and everything, the wheels start falling off. And what's really interesting is when we start moving this camera around, it's almost as if the algorithms can't compensate for that in the first place. So doing a lot of 3D actions on a 2D plane is becoming a lot more difficult without transitioning over to 3D. And yes, there are more 3D based approaches coming now, but if we can achieve this at 2D, it still would be a very good thing to do. So in the future, this is what I believe what we'll see a lot more of this is. The first thing is, I definitely think there's going to be a lot more higher fidelity in the sensor space. We're going to 8K, and with that comes a lot more opportunities that come for scaling up in terms of how many people we can actually process, but also the methods become, not many of the methods that are there don't scale really well. There's going to be a lot more generative based modeling. So going beyond classification and regression to more similarity modeling, more human based models and all that, where that's useful to a human being. These deep learning based models generating some more nuanced framework is actually the gold standard that we're trying to aspire to. There's definitely going to be a lot more real-time based applications. At the moment, that the dancing algorithm is not quite 100% random. 3 seconds is not real time. It's unfortunate, but we're trying to get it faster. There's going to be a lot more stuff related to being more proactive. The methods that we see in terms of anticipation, like the cooking example that I used earlier, can I detect what you can do next if you're cooking something? We've achieved that. That's something that's a reality. And what we're seeing is it's getting integrated into more industrial applications. However, the window of what you can forecast to is very short. That's growing slowly as methods develop over time. And what we're seeing is we're going to see a lot more data and AI driven businesses, especially as it goes out of research, using it out there. And of course, one of the things that I feel very strongly about is that there should be a lot more bringing it home in terms of solving South African problems. There's a lot of problems that are being experienced out there that we can solve today, but there's not a lot of will to want to solve it here. A lot of people are immigrating. A lot of people are trying to. I know that there's one particular collaborator that I'm thinking about where we're solving their problems, but when I talk about, okay, how can we apply it in our context, they don't seem to be very interested in wanting to do that. And then they just say, well, you can use it, whatever, just, I won't be a part of it. And I don't think that's right. We should be allowing us to solve more problems at home and bring those solutions home in the first place. Thank you.
Thank you for the very interesting talk. Do we have any questions from the audience? That seems to have been very comprehensive. There are no questions. I do have one question. Your recipe recognition from like images of food, are there any like commercial or available implementations of it, of your work?
At this stage, no, because it's so tough. We originally we went wild. We were gonna bake a cake, and it was not a good idea. Then scaled it back, like, okay, we're making something more similar, more simple, and then we scaled it back, and that seems to be the theme, right? It only really started working with, okay, great, there's some dough there. Let's take the dough, putting in the oven, and maybe we get some bread, right? So then we are seeing something okay. But what I definitely see is the more nuance there is in the recipe, of course, the more difficult it is to encapsulate it, unfortunately.
Now we have one question now. I think our microphone is on its way.
Yeah, thank you. It was extremely interesting. I guess it's I don't know how on topic it is, but on the sports stuff, which is interesting for its own sake for many of us, I'm sure. Like in this age of Moneyball or whatever, people investing and data driving sports and micro optimizing all these things. Do you think there's a serious like immediate future for this kind of AI analysis in the US, for example, there's lots of money in all these baseball, basketball optimizations, increasingly in cricket as well. So do you think that's like a near-term thing that this AI stuff will give us, analysts sitting in the booth will be using this stuff?
Absolutely. So it just reminds me of, we've got this project that we're running with Emory University in the US. And they're interested in ACL injury detection. They've got a world expert on ACL detection. And what they want to know is, can we determine whether someone has a predisposition to have for ACL injury? And what blows my mind away is it's almost like they've got an open, like a blank checkbook. And it's like, what do you need? Oh, you need how many DGX systems? Don't bat an eyelid. Okay, now it's there. You can use it. Next thing. And a lot of it is all about how fast they want to get it in those environments. So there's definitely a very big push to get it in there now to get that competitive edge. And so some of the big ticket items we see, for example, is for injury. People are very, it's a costly exercise to have an athlete that is injured in some way. So right now for the World Cup, benching strategies, it's quite a hot topic right now. Can we actually do that with AI to determine when to bench? And what we're finding is it's actually very nuanced, and there's a lot of strategy to it. So and the coaches know better. They absolutely know better, but they can't convey what they know into the model itself. So our sort of way of getting around that is, well, okay, instead of just saying, well, good, bad, train a model and do that, we're saying, well, okay, score this, score that, and we build a generative model that can potentially reverse engineer the magic sauce that's in their head that helps them to succeed. We got another one there.
Thank you very much for a very interesting talk. Maybe just a little bit tongue in cheek. From the point of view of using this now, AI is very important. But Rassi Erasmus got into trouble for posting a real video that pointed out reality, and he got suspended. Okay, and that was reality as part of a team. Now with AI, we are trying to predict and making strategies. When are we going to be suspended as a team for making proactive decisions that has nothing to do with the sport? It's just a little bit tongue in cheek. Where do we draw the line? And then I like playing tennis. And I'm not negative. I like technology, and I like technology and AI in various instances. But what I do not like at the moment is the tennis court without linesmen. And a person like McEnroe facing the linesman, in reality. And I just hear a voice saying, out, out, out. When are they going to lose me as the spectator because of AI? Where is the line? Where is the sort of line in this technology, in this AI environment, ethically as well? I mean, you're looking at all this environment, filming, looking at people, and filming them, by the way, without their. You're not supposed to do it, and then you're making proactive strategies. being a little bit tongue-in-cheek at the moment. When are we going to draw the line?
No, you make a very valid point. And I'm a firm believer in a lot of these AI being more an assistive technology than replacing. It should not be taken in isolation. The predictions that are coming out of this should inform the appropriate coach or user, and not in any means replace them. Now, where do we draw the line in terms of whether it's okay to capture and all that? There's a lot of guidance in terms of licensing strategies. For example, for us, it's extremely difficult. Which streams are allowed, which aren't allowed. YouTube versus super sport. There's certain things that come inherently with that, and thankfully there's enough there to know when you are allowed to do it or not. In a personal sense, and I'm with you on that. So I'm an avid squash player. Putting a camera there and then playing there, there's nothing worse than seeing yourself do a terrible job at playing a game. I know absolutely what you're referring to. And if you go into it with saying, well, what do I benefit out of it? What's the value that I get? The value is, okay, maybe my follow through is not good enough, right? And if my follow through is not good enough, what particular situations where I would specifically determine where my follow through is it my backhand, is my forehand? That in itself, if you get value out of it, ideally it should be okay. But you should be in control of when it's on, if that makes sense. Now, of course, for athletes and all that, I absolutely agree, especially with at national level in terms of the athletes. There's a lot of pressure on them to perform. And there's a very big undertone right now in terms of you must perform, give your all, and no questions asked. And a lot of the times there's a bit of an ethical dilemma there where, for example, now there's just another dashboard to look at of how terrible you are at doing something. And we've received a lot of that in some of the studies we've done, and that's by no means our intention. Unfortunately, it's an incidental of what coaches see. Okay, here's another thing I can criticize and see, and tell them what they should be doing. They should be training harder because of X, Y, Z. And unfortunately, that's just what happens.
I just wanted to get things going a little bit, because technology is so important like this, and it benefits. So I don't want it to get the impression that it's negative. It's quite interesting. How do we handle all of this? When are we allowed to have a little bit of skierpapier in our pocket and just shine the ball on one side, and a little bit of AI at the back, or even go onto the court with these funny things and sensors? And just joking. Thanks.
Thank you for the questions.
Do we have any other questions? Okay. If there are no other questions, then join me in thanking Prof. Dustin for his very interesting talk. And Dustin, take it away.